snacks. I can't eat a snack in 10 minutes. Okay, y'all, second example. A little baby paragraph. Y'all ready? You ready, Anita? 41%. Y'all, what is the 41 going to be?
The success.
The success, your P. Everyone thought it was like right on the tip of your tongue. It's bad too when I ask questions. And it's like, hold on, y'all's brain are not thinking about that. 41% of surveyed women say they prefer cats over dogs.
So at this point, we're just back to.
Yeah, it's the little, it's 1, 2, it's about 3 sentences, right? We're going to randomly select so many, and then I'm going to ask you ABC, and then we're going to do ABC. That was just a little bit more work on your paper whenever you get home, different numbers, and then we'll do the distribution. Okay, so 41% of surveyed women. The difference here, remember the 5,000 students that were surveyed earlier? They're not telling us how many women they surveyed. They're just straight jumping into that 41% of the ones who were surveyed say that they prefer cats over dogs. That's my P, okay? You randomly select 12 women. What's 12? I get that it's tedious, like I told you, you know what I mean? But it's not, this isn't hard math. It's just kind of could be more annoying to the ones who don't like math. Okay, find the probability. And y'all, that right there is also your keyword that you're using that formula, okay? Because that is the probability formula for this section. Find the probability that the number of women I'm usually really good at talking and writing, but sometimes I mess up. The number of women who prefer cats is, I need black markers and white out, y'all. Prefer cats. It's A, exactly 2. So I'm going to find P of what? Period. That's it. Exactly 2 means exactly 2. No more, no less. If it says right here for A, exactly 2, I'm going to find P of 2. And that's it. No more, no less. It says exactly. You just find that one. Okay? That's mainly the reason why I want to do this, because it kind of throws in a couple of different things. This exactly means I'm just going to find the P of 2, right? Okay, comma, B. Okay, between 2 and 4 inclusive. So that means I'm going to find the probability of what?
2, 3, 4.
Yep. It said inclusive. Y'all, if it only said between 2 and 4, what am I finding?
3.
That's it. Probability 3. Yeah, just the one that doesn't equal 2 or 4. That's why we're doing it. It's just so you can see the different like words and stuff that they might use. And C between 9 and 11. So this doesn't say inclusive. Inclusive means includes. This is telling me that it does not include whatever numbers they're listing here, which is 9 and 11. So between 9 and 11, not including them, I'm finding the probability of what? That's it. Okay? So it's not, I mean, it's, but it's not horrible, y'all. I do not have to ask myself, is this a binomial experiment? I know it is, because it's straight up asking me all the different probabilities. So I go ahead and I start with my A. Okay. N is the 12, right? Y'all told me that. P was the 0.41 because I need it to be in a decimal. Q is what? I heard it whispered 0.59. My kids think I'm crazy, but if there's one thing I can do, it's here well. Okay? I don't know why I put them in parentheses right there, y'all. Every time we've written it, I have it, but it doesn't matter. Whenever I put it in the formula, I'm going to put it in parentheses, stop. And then,
What did I say?
I don't know, but what I know, X is what? We said if it's exactly 2, I'm only going to find P of 2. Okay. So let's do that. P of 2. I have the formula behind me. I'll go ahead and throw it up right here though. P of X. P of X is who, him?
Oh my goodness, it's crazy.
Y'all are all my favorite students.
Yeah, alright.
The ones who try are NCX P of X. I'm sorry, P to the X. And then Q to the N minus X. Alright, there's the formula. So let's do that. N is 12. C, X is 2. And then P. Don't write the letter P. Actually do the open. Put that probability of success, which is your 41%, which is 0.41. Raise it to the X power, where X is 2. Open. 0.59. Close. N minus X. Y'all, if you wrote 12 minus 2, that's fine. In my calculator, it's a little bit easier just to type 10. That math isn't hard. You should be able to just kind of do that right there in your head. And then guess what? It's only exactly 2, so I can go ahead and just put this in my calculator. And I'm going to do my, this one says round to 3, y'all. Round to 3. But you see the difference, though? We're sitting here and we're talking about it, right? And I can explain to you, like, the ease at how these can be solved.
Yeah.
Imagine not being here and then you see this on the test.
Oh yeah.
And you have no clue what in the
no
world.
clue at all.
None.
So these now.
My goal is to make it easy as possible, y'all. Okay, so I need to do this from scratch. You don't have to. You could go in there and copy and paste and change stuff, but the numbers have altered almost everywhere, so I want to just do it from scratch. Okay, 12, math, probability, option 3. 2, on my calculator, I do need to scoot over, okay? I open my parentheses, I do my probability of success, I do my caret, and I hit the number 2. I scoot over, I open up my parentheses.
A equals to the answer? So A would be.
Oh, I think once I actually got it and rounded it, I didn't even do anything. I would just type in the computer, but maybe put a square around it or something, like box it in. I'll show you. I didn't do anything. I'll show you what I did. Raised to the N minus X is 3, 2. Oh, you stop asking me questions. I'm sorry. I wrote it right here. Tyler,
What a weird.
right here. Where it says round 9.
Just now with that. No way I'm mistaken.
Written is 12 minus 2. And then I hit enter. And then I look at my calculator. I feel like I could kind of skip past the intermediate step of showing you how to round. Okay, I believe that if someone doesn't know what I'm doing, they will say something to me. 0.057 is your answer. And maybe if you wanted to do something like this at the end, you could, just for your paperwork, you know. But you would just type that into my math lab. Okay, moving forward, I'm just going to kind of talk while I'm working through these. This one has the ability to be lengthy, so let's just work through it. N doesn't change. P doesn't change. Q doesn't change. My X is going to change. It says between 2 and 4 inclusive. So that's 2, 3, and 4. So I just do 2, 3, 4. And I know that after I find those, I'm going to sum them up or just, add them. And this one tells me round 6. Ding, ding, ding. I don't know why I did that. Okay, so I'm going to do probability of 2. Sometimes it works out like this, sometimes it doesn't. Didn't we just find the probability of 2? It's the last thing I found in my calculator. Don't write 0.057 here, because it told me to round to 6. So, but I can look at my calculator, and I could just look at the answer I have here and round it to 6 places, okay? Might not work out like that again, but if it does, take the shortcut. 1, 2, 3, 4, 5, 6. I went up wrong. 0.056706. I had already entered it into my calculator. Look at your calculator. What was the last thing? Or look at your work. Look at A. What did you find on A? Probability of what? And look at the first one you're finding on B. Probability of what? So here, I had to round it to 3 places. The next, it's just like a shortcut. I was like, oh, hey, I already did this. That's why I'm just like, oh, I can look at my calculator, and I just round it differently. Then do it. Yeah, I do it the other way. This was gotten from my NCX P to the X times Q to the N minus X. Which is fine. Every now and then if I see something though, I'm known to take a different exit off of the same road that we're all on. Okay? So I'm going to go ahead, I'm going to grab my calculator. And then whenever I look at my calculator, I notice that I just entered all that into it. So I have the answer right there. Okay? And so I get 0.056706 because I needed to round it to 6 decimal places. Now I do P of trace. And I haven't done this one, and Tyler wants me to do all the steps. I'm just kidding. So N 12, C, X is 3, open 0.41, close to the X power, which is 3, and multiplied by our Q. And then right here at your C, that's your subtraction. 12 minus 3, right? That's what I'm subtracting. That's N and X. Subtract those. 12 minus 3 is 9. And then aren't I going to have to do P of 4 too? So I can go ahead and do that and change the appropriate numbers. Right here, that's my subtraction. 12 and 4. 12 minus 4 is 8. Get your calculator, grab an old one, scooch. 3, 3, and the 9, being sure to delete that 0. Yeah, you could do that. Yes. Yes, he says. The distribution, definitely do it, because there's like 12, 8, 9, 10. Like they have you do a lot of them. Okay. What am I doing with my life? Round to 6 decimal places. 1, 2, 3, 4, 5, 6. I get 0.131354. And then I'm going to go and grab, and I'm going to change my 3s to 4s, and I'm going to change that 9 to an 8, right? Okay. What you need, Avery? Okay, and when I round this one, I get 1, 2, 3, 4, 5, 6. 0.205379. I want to. Those are my favorite. Okay, and then those are my favorite. And so those are the peanut butter ones. Freaking awesome. And so for the probability that the successes are between 2 and 4 inclusive, I found the probability of 2, 3, and 4. If you see this notation, between 2 and 4, so here's my 2, there's my 4, right? I kind of probably should give myself a tad bit more room. But it's saying that the successes lie in between there and include. So X could be greater than or equal to 2 or less than or equal to 4. That, in math language, is saying between 2 and 4 inclusive, which is the includes, which is why it could equal. And then all this is P of 2 plus P of 3 plus P of 4. Grab your calculator. And do 0.056706 plus 0.131354 plus 0.205379, enter. I get 393439. Y'all get that? Okay. 0.393439. I kept it at 6, so I guess either I stopped paying attention to where it said to round. If it said to round at 3, round at 3. It's round 4, 5, 5, 6, 6. Whatever it says. Pay attention to the rounding, because I could definitely get you. You gotta be quicker than that. I want to smush right here what I need to do for C, if y'all are okay with it. Between 9 and 11, right? Between 9 and 11 is only one number. It's just the 10. So I think I have enough room here to go ahead and do it. I just have to smush it a little bit. Okay, so for C, and y'all, if you haven't noticed, it's been kind of redundant with the N, the P, and the Q. Those haven't changed. The only thing that changes is your X, but I keep writing them. What if I change pages or do something and I don't remember what it is? Having it written down helps me. Here, the only number that is in between 9 and 11, and it does not include 9 and 11, is 10. Therefore, the probability of 10 is going to be NCX P to the X times Q to the N minus X. There you go. Copy, highlight. Scooch all. Why did I say 10? No one said anything to me. And it's 12. And then at the end, your last exponent should be a 2. Because I saw 10s here that were the same, that's why I made it 0. And no one said nothing to me. Okay, so I changed my previous X right here, which was a 4, to a 10. Everyone should have gotten, and here it was also a round to 6. Should get 1, 2, 3, 4, 5, 6. 0.003084, and then that is just your answer, right? If it was like between this and this and you had all these at 4, that's when you take the sum of them. If it is just the probability of one of them based off of the words that they use, then it's just that one. That's just the answer. You don't sum it to anything, okay? That is the actual probability that the number of successes from the 12 random people that I grabbed from the 41 that said yes, that's the probability, 0.003084. Everybody good with that? Okay. Yay, math. Let's move on. Yeah, ask me twice. I'm gonna wait to eat them. Give them more. There you go. Oh, thank you so much. So my favorite ones are the brown ones because I think they taste. No, the brown ones taste better because they don't have as much artificial coloring in them. I'll literally only eat the browns. I know.
Don't they have brown M&Ms? Is it pure brown?
My birthday's coming up.
Coming up in like a year.
You don't celebrate your birthday every month. That's on you.
Every month.
Okay. Okay, y'all. So we're gonna have to do the mean, the variance, and the standard deviation. The variance, that was the hard one in the 4.1, right? Like the really annoying big, huge, long table, how to compute it by hand. Here, the variance, actually, it's not the variance. You don't calculate the variance. It's just the standard deviation. And so because we don't have to do the variance, we don't have that big, huge, like, table. The standard deviation, we're going to take, it's a different formula. I'll show it to you. So there's similarities in what we did before, but it is still easier than the 4.1. Okay. Construct a binomial distribution. I'm just curious. This is not going to be able to be used. I just want to see how big this writes. 2 points. Okay. Oh, I'm not falling in love. Construct a binomial distribution. So pretty. It's blurry for y'all.
Wait, which one?
The way it writes.
My hand's tired.
Right. Welcome to the club. Why is it like blurry? It won't focus.
Let's use whiteboards.
No,
Why?
because I have to like delete the board every now and then and move around.
You got the groups. You quizzed us like a little daily grade.
Well, definitely not a daily grade. You're making me work way too hard.
Huh? You did the easy one today and we don't need it.
No, I have an exercise that y'all are gonna do. It was for 4.1, but I'm gonna wait to give it to you. Okay, example.
So we're calling math problems
Exercise your brain.
No, stress.
Okay. I numbered it the first example, but honestly, it's the only example we're gonna do, so you don't have to number it anything. Ready? 24% of working mothers do not get enough sleep. Period. I go to bed at 9:30, wake up at 3:30. You select, so yeah, I think so. You select 6 mothers.
Did you say you home like at 7?
I used to when I worked at Tyler at TJC.
You got 2 hours.
Yeah, which was nothing, it's cooked. You select 6 mothers and ask if they get enough sleep. Create a binomial distribution graph and explain. Identify any unusual, how do you spell unusual? I'm doing it right. Unusual, it's a weird word. Unusual variables. And then in parentheses, I put less than 0.05 because that's what I noticed. I looked at the different examples that y'all have. I even Googled it just to make sure because it doesn't explicitly state what makes something unusual. But I noticed that if the probability of something occurring is less than 0.05, you say it's unusual. I even opened up the slides and it didn't even say anything exact. So we're going to go with that because it seemed to work out every time I used it. Okay. So let's look at what we have here. Let me switch to colors. I think I have all different kinds of colors here. What is my N? N is the number of trials. 6, yep. And then my P is what? The 24, but you write it as a decimal, so 0.24. With that P, I can figure out what my Q is, which is 1 minus 0.24, which is 0.76 to be exact. And then my X is going to be the number of successes, which is, why do I have, okay, sorry. I don't know why I had that right there. Remember it's 0 all the way up to your N. So 0, 1, 2, 3, 4, 5, 6. X is 0 to your N. So 0, comma 1, comma 2, comma dot, dot, dot. I'm lazy 6. Tells me to round 3. So let's create this binomial distribution. Okay, so A. This is what you see. You see your x's. So 0, 1, 2, 3, 4, 5, 6. Very similar, but honestly, I think it's a lot easier. It's still using this formula up here. Did you say you didn't like it? It's still using this formula up here, so it can get tedious, but it's 4.1 was a little bit more than 4.2 is, okay? Yeah, I'm going to put the whole work right here. And
on every single one? That's 6 problems right there.
but just watch. Oh my, I swear. Ready? Okay, and then in order, okay, listen on the homework, this is what you see. You see your x's listed, and it's in a table, and it says p of x. Here are your blanks. These are where your blanks are. This is what we have to figure out. So we have to use that formula because that's how you figure out your probabilities. So let me actually grab something that's like little. Well, maybe, probably. Nope. Yep. It's purple. You ready? So I need to figure out what the probability of 0 is. And I know that it's NCX. N is 6, C, X is 0. Open, put your successes, raise it to your X power, which is 0 in this case. Open, put your failures, and raise it to N minus X. What is 6 minus 0? 6. Now watch this. You can fill it all the way out, go all the way down. No reason to pick up a calculator yet. Whenever I do P of 1, watch 6C what? 6C 1. Open 0.24, close what? 1. Open 0.76, close. Look, here's your subtraction now. Right there. The N and your X. That's what you subtract. 6 minus 1 is 5. And then put your equal sign. We're going to go ahead and I can put all this on here. That way if I make a mistake, I have notes and I have work that I can recall and I can go and I can look at. Now let's do P of 2. That's 6C2. Open 0.24 to the second power times 0.76. 6 minus 2 is 4. And look at this. Look right here. Can I show you something? This is the patterns that I'm talking about. Okay, so look at it. The 6's will never change, right? The C will never change. What happens to my x's here? Isn't it increasing with 1, 0, 1, 2? So 0, 1, 2. And then this last exponent, 6, 5, 4, 3, 2, 1, 2. Right? This one goes down, this one goes up, and this one follows. And it goes up also. That's what I saw. And I was like, oh, I'm just going to fill all this out, and then I'm going to grab my calculator. 6C3, open 0.24 to the third, raise to the third, P to the 4, P to the 5, P to the 6, and then I started doing this. And y'all have to follow this. This is just, if it helps somebody, do it. What did I notice? The 6's in the front, they stay the same, right? So look what I did. I was like 6, 6, 6, C, C, C. 0, 1, 2, 3, 4, 5, 6. Each time I do the 0.24. And then I notice 0, 1, 2, 3. So that must be a 4, a 5, a 6. That's why formula is beautiful. And then each time I multiply it by the failures. And then 6, 5, 4, 3, 2, 1, 0 equal. Now, start with the first one, and all you're going to do is round it 3 times, put your answer, copy, and change what you need to in your calculator. And I did an equal here, y'all, but there's no reason to write it twice. I'm just going to put the answer right here underneath the P of X, okay? So I grab my calculator, okay, and I do 6, Math probability, option 3, 0, I scoot over, open 0.24, close, raise that to the 0 power, scoot over, open 0.76, close, raise that to the 6 power, and I hit enter. Okay, and what I notice is I get 0.193. I said I wasn't going to write it here, but I did. And right here, 0.193. I wrote that word. And now I'm going to do it, and I change what changes, which is my x's and my n minus x. So I go up and I highlight. And I do 1, 1, 5. Rounded to 3 decimal places. 1, 2, 3. 1, 2. Can't write like that. Do it again. Second verse, same as the first. 2, 2, 0.288. Okay, that is kind of the cutest little eighth I've ever written in my life. This is when you're like, y'all watching at home, you could fast forward this for the next 5 minutes. I do 3. 3. 6 minus 3 is 3. 0.121. 4, 2. 0.123, 0.029. Zero, 4. And last one. 6, choose 6 with the probability of success being all 6 and the probability of failure being none. That's kind of how you would read that. You notice super tiny number. Very unlikely that out of all the 6 that you asked, they all said yes, they don't get to sleep. There's going to be somebody that might say no. Oh, sorry. But you notice, like, you really read it and stuff, it should kind of make sense what's happening here. Because it's moving to the left 4 times, what's happening is I'm adding 3 zeros in front of my 1. Okay, so I go 0, 0, 0, 1, 9. It says I'm rounding to the third, which means this is actually 0.000. It's a 0% chance that if I select 6 mothers, all 6 are successes, which say yes, they don't have sleep, and none are failures, which they know they don't get enough sleep. Okay, that's kind of reading it in like the real world way, but it's 0.000. Now, here's the one thing that y'all know I can't stand when I can't understand anything. We did the table all by hand last time. Just technology was not my friend. For part B, I didn't put those here, but for part B it was graph. Remember I told y'all, you should be able to look at your data, and you should be able to look at the graphs, and you should be able to figure out which one is what and kind of like what's happening to it. I literally just looked at all of my different data points. This is technically function notation, so what it's saying is when x is this number, this is what y is, right? So that's what, like a graph would do, and so the bar graph is going to follow that same trend. So when it tells me to graph, I put in parentheses by inspection and describe. That's B. Okay, well, what do I notice? I notice that when x is 0, I'm almost to like 0.2, right? And then x becomes 1, I'm at almost 0.4, so it went up a little bit. And then now I'm going to 0.3, and then 0.1, and then 0.2, and then 0.004, and then to nothing. So I notice that it's going to be skewed. It's going to go like this. I'm not really going to draw it at all correctly. but say it's at 1, then it went up to almost 4, then it went to 3, then it went back to 1, then it's getting closer, and then, oh, it's literally 0, right? That's just me totally rough sketching this. And I noticed that it ends up going down like that. This would be skewed to the what? Left or right? To the right. This would be skewed to the right. So I would just look at all the, they're going to give you like 4 options. Literally go to 0 and see where does it show the bar going up to, okay? I wish, I'll ask somebody. I still haven't because no one's been in the office, but when I do this, I notice that it's skewed right. Okay. And then now for part C and the last part. Identify any variables that are unusual. I put up there in the little question that if a variable is less than 0.05, it's considered unusual, right? And so they didn't tell me this at first. I'm telling y'all that now, moving forward. But what they're going to want you to do is you first have to figure out what the mean is and the standard deviation, and then the last step is to identify unusual. We can already tell what unusual is. What here is less than 0.05? When x is 4, 5, 6. Yeah. Okay, and that's like the last chunk. What it tells you to do first is to, in order to figure out which ones are unusual, what is the mean? That's how you find the mean though. The mean here is n times p. What's my mean if it's n times p? What's n? What's p? 0.24. Put that in your calculator. It tells you to round to the tenths. You get 1.4.
You get it. Dang, I typed it wrong.
In hindsight, I probably shouldn't have told y'all right here that if it's less than 0.05, it's unusual, because then like my mind went straight to just the answer. And they have you do a couple of little steps before you answer that, okay? So the mean is n times p, n is 6, p is 0.24. It tells you to round to the tenths place, you get 1.4. Okay? Then it tells you to solve for the standard deviation. And it tells you the way, usually the standard deviation is what? The square root, Tyler said it earlier, the square root of the variance. Okay, but it's not asking you to do the variance. So they actually give you what they want you to do, which is n. You take the square root of n times p times q. Square root of n is 6, p is 0.24, q is 0.76. Tyler, put all that in your calculator, round to the tenths place. What you get?
I get 1.046.
And then round to the tenths.
1.0.
Yep. So that's the mean, and that is the standard deviation. Now, again, y'all know I just do the example, so I don't know exactly where, is there a blank, is there a pull-down menu, like how do they have you answer this sentence right here? But this is what it says, and this is what you need to write down. And then whatever it says on the homework, y'all are welcome to ask me, obviously. Okay, so on average, isn't the mean the average, right? So on average, I'm assuming this would be like a little blank you fill in. On average, 1.4 of 6 mothers, because that was my n, do not get enough sleep, comma, with a, and I'm going to shorthand this though, with a ST period DEV, with a standard deviation of 1.0 mothers. Definitely does not make sense as far as English is concerned, but That's us putting it into words. There's an average of 1.4 because that's the mean out of the 6 individuals that I did this trial on that don't get enough sleep. And I also calculated that there's a standard deviation of 1.0 mothers. Now there's one more spot that I need to write on, and it's not gonna be, let's do this. Here's my unusuals, y'all. I'm just kind of moving it right here so I don't have to keep smushing it on the bottom. Okay. It's like identify the unusual variables. Okay, so the variables, x equals 4, comma, x equals 5, and x equals 6 would be unusual because their probability is less than 0.05. I shorthanded things. If y'all don't get it, tell me. When it's like, oh, you know, what variables are unusual? You might just enter 4, 5, 6. I don't know. I'm trying to make as wordy as possible so that you'll have everything you need to answer it. But the variables, x equals 4, right here, right? And x equals 5, right there, and x equals 6. Those would be the ones that would be considered unusual because their probability is less than 0.05. Now we're dropping the mic. We're done.
I'm gonna do all this and study alone. Questions.
Do it. Yeah, y'all can email me always. How do I, why is this not working?